All right, here's the intermediate value theorem. So intermediate is like in between. So that's basically what we're going to talk about. It's going to be the in between value. So let's kind of think of this logically. This is the mountain to mathematical promised land. If I climb a mountain starting at an elevation of 1,000 feet, so here we are, starting at 1,000 feet, okay, and I want to end at an elevation of 5,000 feet. First, must I have passed through an elevation of 2,753 feet? Let's think about this. First of all, these values of 1,000 and 5,000, they are not our x values. Like I am starting here at time t equals 0. Okay, that's like your x value. My y value would be, I'm at, not 0. My y value would be here at 1,000 feet. Then let's say maybe time would be like, I don't know, 15 hours later. Okay, I'd maybe be at 5,000 feet. That would be my y value. My x value would be the 15 hours. I'm wondering at what time, so at what x value, I don't know, there's got to be some time that I pass through this y value. That just logically makes sense, right? So now let's associate that with math. Okay, so a definition you have got to know. The AP test loves this theorem, along with another one that's very, very similar. So I strongly encourage you to make a note card. Make a note card. If we were in class, we'd be making a colorful note card of this. Make a note card. Go onto Amazon, buy some colorful note cards or construction paper. So very important. You need to know the wording inside out, backwards, forward, verbatim. If f is continuous, that is extremely important. It must be true that f is continuous. On the closed interval from A to B, okay? And k is a number. So our closed interval would be like we start at 1,000, end at 5,000. And k is a number. That's like our 2,753. Such that f of a, these are our y values. F of a is less than k, is less than f of b. Then there exists at least one number c. These are now our x values, such that a is less than c is less than b, such that f of c is equal to k. Now, what exactly does that mean? Just that it's saying that there is some y value that'll equal k at some point. So simply put, what we are saying, if f is continuous, so if our function is continuous from our a to b, so our function is actually continuous from our a to our b. So you see here, our function is continuous from a to b. There we go. Then it takes on every value between f of a. We get every single value between a and b. Now we get some other x value here. That's saying that this f of c, that's just a y value, has to equal this k value that I'm setting. That's like that 2,753. That has to happen because it's a continuous function. You will pass through that line. So if I told you that, I don't know, this is f of a is the value of, let's say, 1. F of b is the value, so that's your y value of 1. F of b is the value of, let's say, we're ending here at 6. Will you ever hit 4.7? Well, absolutely. If this is continuous, you have to pass through 4.7. Okay? We'll be using this, we use this in like algebra, going through negatives and positives to prove that roots existed. You did this kind of before. All right, so now let's actually get into examples. Again, Make this definition into a note card. This is one of the first note cards you should be making to start your AP note card collection. This exact definition right here, and we're going to be writing it out today several times, how it should look on like your AP test. Okay, it even was on last year's AP test. All right, so kind of looking at this chart, okay, using the graph below for both A and B, this problem, it's telling us f of x is continuous. So they gave us a table of values. They also graphed out that table of values for you. Okay, kind of. They just did not go up to 105. So they're saying at -4, we're going up really high. And at 4, we're going up really high. So it's saying, does f of x have to equal the value of 3? So you can either graph it out if I wasn't graphed out, or I could look at my table of values. Well, looking at your graph, you can obviously see, well, yes, absolutely, we have to equal 3, just visually looking at your graph. And visually looking at your graph, so yes, it does equal 3. How many times? Well, looking at my graph, once, twice, 3 times, 4 times. Absolutely 4 times. Now, could I tell if I was not given a graph, because you're not always going to be given a graph, would I be able to actually tell just given a table of values? Well, look at your y values. Where does the y value, this is just saying f of x equals 3. F of x, which is just y, where does y equal 3 happen? Well, look at your y values. Between 105 and 0, does 3 occur? Absolutely. 3 happens in between here. Now, does 3 happen in between 0 and -15? Nope. Does 3 happen between -15 and 0? Nope. Does 3 happen between 0 and 9? Absolutely. That's the second spot. Does 3 happen between 9 and 0? Yep, that's spot 3. Does 3 happen between 0 and -15? Nope. Does 3 happen between -15 and 0? Nope. Does 3 happen between 0 and 105? Yep. There's our fourth spot. So you could tell by a graph or by a table of values. All right. Next question. On the values, the closed values of 0 to 2. So again, we could look at x. This is saying let x equal 0, and that's my first x. This is my second x. So I am going from this value. Those are the spots I'm looking at. So don't get it confused with an XY coordinate. We are looking over these values. If you are looking at the graph, we are looking from here. Must it be true that f of x equals 6.2? Now this is saying, does y at some point equal 6.2? Well, let's look. If we're looking at our graph, the graph is super easy. Go to like 6.2. Well, sure, we equal it, and we equal it once. 6.2 would fall there. Absolutely it does. Yes. Now, let's look here. Between 0 and 9, does 6.2 lie there? Absolutely. Between 0 and -15, it doesn't there, but we know between 9 and -15, sure, 6.2 has to occur. So that is our IVT theorem. Now, are they going to be as easy as that? Absolutely not. Let's get to a real scenario question. All right. So, real scenarios, like what you would see on a multiple choice or a test question or maybe an assessment, a summative, or an AP question. First, if we're given this function, let's first look at this function. G of x equals x cubed minus 5x squared plus 8x minus 9. You have to first ask yourself, the first thing that we need to know, is that function continuous? Absolutely. You need to relook at your functions. An x cubed graph goes like that. An x cubed graph in our family of functions, that is continuous. And it's over our bounds. Look at your bounds. Is there a value between 0 and 5? That function is continuous over our bounds of a to b. Our bounds of a to b are 0 and 5. That is absolutely continuous over those bounds. Now it wants to know such that g of c equals 27. If so, justify your answer. Well, first, I want to find if this value of 27 is in between my g of a. Is g of c in between my values of g of a and g of b? All right, so we need to first figure out, okay, what is g of a? Well, g of a, my a value, remember, is 0. So let's just plug and chug. G of 0 is plug 0 into our function. 0 cubed minus 5 times 0 squared plus 8 times 0 minus 9. I believe g of 0 just equals negative 9. Now let's find our g of b. Step 2, find your g of b, which that is your g of 5. 5 cubed minus 5 times 5 squared plus 8 times 5 minus 9. To save time, I will let you know g of 5 ends up being 31. Double check my work. Now, what you have to ask yourself is, it's asking if so, does 27, does that lie between the values of the y values of negative 9 and 31? It sure does. So we then need to justify. What would you be writing on the AP test? To justify, we will write, this is what you need to memorize. This is what you would write on a test or a quiz or the AP. Since g of x is continuous, you would be deducted points if you do not say that. Since g of x is continuous and 27 is in between g of 0 equals negative 9 and g of 5 equals 31 by the intermediate value theorem. I would write that out on the AP. There exists some value C between 0 and 5 such that g of c equals 27. That is the justification. I know that that is a lot. That is what you need to have memorized. Make a note card. That is exactly how you need to have that written. All right, star it, mark it, know it. Very, very, very important. Very. Now, moving on to the next one. A car travels on a straight track. The car's velocity V of t is a continuous function, and the table below shows selected values. So let's look at this. V of t is my velocity. That's in feet per second. T is my time in seconds. It's asking what is the car's average acceleration, and we're going to worry about that a little bit later, not right now, but they're asking it now. Average acceleration. So this isn't as important right now because we're doing intermediate value theorem, but average acceleration's formula, that is the change in velocity, so that's V of t, all over the change in time. So anytime we're doing change in something, think of that as slope. Think of slope in algebra, okay? So think of like V of 2 minus V sub 1, oops, that's not a 1, V sub 1 all over T sub 2 minus T sub 1, okay? So now, think of our units. What would our units be? Because you need your units. V of t have feet per second all over seconds. So what would that be? Now, I'm going to put that over 1. Fraction over a fraction. Multiply by that reciprocal. Multiply by that reciprocal. That makes these ones cancel. However, up top there then, we end up getting in the end feet per second squared. There we go. All right, I'm going to shrink that down so that we can actually do the work for that problem. All right, so now we want to find the average acceleration from time 15 seconds to 50 seconds. So we want time 15 seconds to 50 seconds. So really, it's asking us to take V of 50 minus, because that's my V of 2, minus my V of 1, which is 15, because this is really T sub 1, T sub 2. So all over 50, that's my T sub 2, minus T sub 1, which is 15. So think of it, y2 minus y sub 1 all over x2 minus x sub 1. Well, what is V of 50? V of 50 is 0 minus V of 15 is negative 30 all over 50 minus 15 is 35. So we really have 30 over 35, which simplifies to be 6 over 7, and our units we found to be feet per second squared. That would be my average acceleration. All right, again, we're not going to worry about that as much. What we care about is our intermediate value theorem, and I'm seeing already something in between something. So for 35 is less than t is less than 50. So I see something in between something. So I'm thinking already this is probably an intermediate value theorem question. Must there be a time t, okay, when v of t, that's a y value, equals negative 5? Well, let's take a look. So we are probably looking at, I'm going to switch colors, we are probably looking at time 35, and we are probably looking at time 50. So let's go to that chart. Time 35 is here, time 50 is here. So when I look there, must there be a time t when v of t has to equal negative 5? So now let's focus on our v of t. Here's our v of t's. Let's think. In there between 35 and 50, look at those values for me. We at v of t go from negative 10 to 0. Do we ever, from negative 10 to 0, will you pass through, and will your y value ever equal -5? From -10 to 0, if you go from that number line, why, absolutely yes, you pass through -5. Now, how do I show that? Well, one, you find and say v of our first one, v of 35. Well, what is v of our first one? V of 35 is -10 here. Okay, our second thing, v of our second thing. This is our A. This is our B value. It's going between 35, remember, and 50. This is your A, this is your B. Our V of our B value is equal to 0 right here. Now, sure, you do get -5. You do pass through that. But again, we need to justify. We need to use that theorem, our IVT justification. So since V of t, don't forget, is continuous, time is continuous, and -5 is in between V of 35 equals -10 and V of 50 equals 0 by the IVT, but you would write the intermediate value theorem. There exists some t value between 35 and 50. I should just say some t between 35 and 50 such that V of t equals, oh, do I run out of room? V of t equals -5. There you go. Last but not least, it says, that's an F, let F, that's an F, let F be a continuous function such that, now they're telling us f of 2 equals 5. So they're saying that's my x, that's my y, and f of 5 equals 2. Now we've got a new function, h of x. Let h of x equal f of x minus x. Does h have at least 1 0 on 2 is right there is screaming at you. That is saying use your IVT. So first we need to check and find our, this is our A, that is our B. So first we need to, does h of A. So step 1, find h of A. So we first need to find h of 2. So we need to use this function here to find h of 2. So plug in 2 everywhere there is an x. So plug in 2. I got h of 2 equals, well, keep that f of 2 minus, well, then 2. Well, what is f of 2? They told me here what f of 2 is. F of 2 is 5 minus 2. So we get 3. So h of 2 is equal to 3. That's my A value. Now let's find my B value. So 2, my B value is plugging in 5. H of 5 is equal to, plug in 5 now everywhere there's an x. F of 5 minus 5. Well, f of 5 they gave me. F of 5 is equal to 2 minus 5, which equals negative 3. So my h of 5 equals negative 3. Now, let's answer our question. The question is asking, does h have at least one 0? What does that mean? A 0 means, does h of x equals 0? Think about that. That's saying, does it cross the x-axis? Well, between negative 3 and 3, do we equal 0? Sure, we pass through 0. Is 0 in between that? Absolutely. So how do I write that? How do I justify my answer? We say yes, since h of x is continuous, don't forget that, continuous, and 0 is in between h of 2 equals 3 and h of 5 equals negative 3 by the intermediate value theorem. There exists some x between 2 and 5 such that h of x equals 0. I will take questions next time in class. Email me if you have any other questions. Have a good day.